Hey, Math 10. Today we're going to be looking and continuing on about central tendency and talking about that. We're going to be looking at range and how to graph it. Okay, I got a little bit different format. I don't have the normal PowerPoint because for some reason my PowerPoint has been acting up. So we're going to be working off of OneNote, but nonetheless. Anyways, remember you can also follow along by downloading the notes from Microsoft Teams so that you have a copy of this and you can practice doing this. Anyways. Here's our first question right here, or first two questions. It says, let's find the mean median mode of these sample groups right here. So try putting the video on pause and see if you can do it. And hopefully if you unpaused it, you'll be able to work along with me right here. I'm going to pick the green, or I'm going to turn that to red. Okay. So first off is that we're going to calculate the mean. If you can't remember how to calculate the mean, you have to add up all of these numbers. So I'm going to do that really quickly. So I'm going to go 22 plus 22 plus 22 plus 23 plus 24 plus 24 plus 24 plus 25 and plus another 25. And I get the number 211. Okay, so to calculate the mean, you have to add up all the numbers and divide by how many numbers there were. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers. So divide by 9 equals, and I get 23.4. 0.444 repeating. But anyways, that's my mean or my average. Okay. Now I'm going to calculate the median. So in order to calculate the median, I cross off, first I have to put all the numbers in order from smallest to greatest. And then after I do that, just cross off the smallest, then the greatest, next smallest, next greatest, until I get to the middle number. If you have two middle numbers, remember you take the average of those two middle numbers. But here we only have one middle number, and that is the number 24. Okay. So now I'm going to pick the mode. The mode is the number that we see most often. And so for the number 22, I see 22 3 times. I also see the number 24 3 times as well. Okay. So here we have a tie between 22 and 24. 25 we see twice, but that's not the most. So our mode is going to be 22 and 24. What we have here is something called bimodal. Okay. Now our new word, and for our lesson today, is the word range. And range is the difference, and difference means you subtract difference between the largest value and smallest value. Okay, so our largest value is 25, and so our largest value is 25, and our smallest value is 22. So our range is going to be 25 minus 22, or in other words, our range is 3. Okay, so that's our new thing that we're going to be doing today. So we're going to talk about what does a range mean. But before we talk about what a range means, is I want to talk about this next set of data and calculate the mean, median, mode for this set of data. So again, same thing. Calculate the mean. I'm going to add up all these numbers. So 4 plus 22 plus 22 plus 22 plus 24 plus 33 plus 46. And I get the number, when I add these all up, I get 221. I also have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. And so when I find out that, the mean is 24.5. The middle number is 24. The most represented number, or in other words, the one that we see the most, or the mode, 22 we see 3 times. And 24 we also see 3 times. So 22 and 24. So these two sets of data from 1 and the data from number 2, are very, very similar. We have a mean that's very similar. On the first one, 23.4. On the second one, 24.5. So the averages, or the means, are very similar. The medians are exactly the same. The middle number is 24 for both of them. And they're both bimodal, with 22 and 24 being their modes for both of them. So let's take a look at the range. So we're going to take the biggest number, which happens to be 46, and the smallest number, which happens to be 4. And so we're going to go 46 minus 4, and that's going to equal 42. Now, this is where the data gets way, way different. Okay, so the range for number 1 right here is 3, and the range for number 2 right here is 42. Okay, so what does that mean is that this one, number 1, the first sample, has a lot tighter data. It's a lot more clustered. That means it's much, much closer together. And the range on number 2, it's a lot more spread out. So how can you use that in real scenarios? So imagine this person is a lobster fisher, okay? And this person is also a lobster fisher. And they go out and they have to catch their lobsters and come back. Well, the person from boat 1 would have what we would say a consistent income. So what that means is that a lobster fisherman gets paid by how many lobsters they catch. Okay, and so for this person right here, they're catching 22 on maybe the first day, 22 on the second day, then 23, then 24, 24, 24, 24, 25, 25. So they're catching pretty similar catches every single day. So the boat 1 will have an income. How much money they make will be quite predictable because we know that the range is very, very small. However, in boat number 2, some days they may make a lot of money, by like this day right here, 46, making almost twice as much as a normal day of fishing for them on that one particular day. And even this day right here, they're making a very, very good wage. But some days they're making a very bad wage. They only got 4 lobsters on here. So if that meant income, or how much money they make, that'd be a very inconsistent income. Okay. And this can go further, and it helps people like look at data a little bit more and kind of analyze it a little bit better. Anyways, so this is why range is important to also include. It is not a measure of central tendency. It is not a measure of what the middle is, but it is kind of a measurement of how spaced apart is the data. Okay, the next thing that we're going to be looking at is how to graph central tendency. So what we're going to do is we have a bunch of data right here. And we're going to put, and this data right here are called values. That's right there. And we're going to put the values down here on this graph. Okay. And we're going to put how many times we see these values right here, or in other words, the amount. So for values, well, we have 1, 2, 3, 4, 5, and 6. Now, how many times do we see these values? So here, we see the number 1 only once. So if I'm going back to here, the amount of times we see this is 1, 2, 3, 4, 5, 6. Okay, so we only see that one time. We see the number 2 times though. So here's the number 2 for the value, and we see the number 2 times. And then we see the number 3 times. Okay, and then we see the number 4 2 times. And then we see the number 5 once. And we see the number 6 no times, so that's why it doesn't even get anything. And then what we end up with here is we get what is called a distribution graph. So this graph is a distribution graph. And it's very good in making predictions and helping us understand a few different things about averages and stuff. So this is called distribution. So this is a distribution graph. Now we're going to take a couple of looks at distribution graphs and see how to interpret them, okay, and how mean, median, and mode kind of fit with these distribution graphs. So here we have a distribution graph right here. Now, this distribution graph could be something like, a very common distribution graph would be, say, height. So let's imagine that we have height right here. Okay, this is the amount of people. So if we had an axis going up here, this is the amount of people. And here on this x-axis is height. So let's say right here is 5 foot 8 inches tall. Okay, and then down here would be someone considered very, very short. Okay, and over here would be someone very, very tall. So let's imagine right here is 7 foot 5 inches tall. So very few people are 7 foot 5, and that's why the amount of people that are 7 foot 5 is way over here. Very, very few people here. Okay, and then down here, this might be like 3 feet tall. Okay, and there's not a lot of people that are 3 feet tall. So we'll imagine we're having something that's adults. Not a lot of people are 3 feet tall. So it'd be very, very few. And then most people, there's lots and lots and lots of people that are 5 foot 8. Okay, and so that's why the amount of people right there is very, very high. Okay, so this would be a distribution graph right here. Now, where is the mean? Now, imagine we take this distribution graph, and I'm going to kind of graph it again really quickly. Okay, and let's imagine that we turn it into like rather than a line, we turn it into like a solid object, something like this. I wrote down the mean is the balance point on the graph. So imagine if we had this and we had to place a fulcrum or like a little small object underneath it in order to balance it. So here's our fulcrum, okay, and we had to place this somewhere underneath here. So let's imagine we place it right here, okay, and then we say this thing has to balance, this object right here has to balance on this little fulcrum right here. Well, if we place the fulcrum at this location right here, this object would fall down. It would tip down this way. So it would not be balanced, okay? So at this location right here would not be the mean. That is not where the mean is because it can't balance on that location. So where would we put it so that this object would balance? Well, I think that's kind of obvious. We'd place it right here. Now, this is where if this object was balancing on this little fulcrum, it would balance at this location. So this location right here is called the mean. So this right here is the mean because it's the point at which it would balance. Now the median is the area is equal on both sides of the graph. So again, I'm going to take a look at this graph right here, which is pretty much the same as this one. And if I kind of cut it right here, and then I fill in this area, okay, this area that I filled in is probably equal to this area right here that I'm filling in. So these two areas are equal. Since the amount of green is equal to the amount of red, then that would be considered the median. Now you're probably looking at this already and saying, hey, the mean and the median are exactly the same. And we're going to talk about that in a second. Okay. Now the mode is the highest part of the graph. And well, as you can clearly see, the highest part of the graph is right there. So that would also be called the mode. So at this point right here, it would be the mean, the median, and it would be the mode is all at this point right here. In other words, if this was a height distribution graph, the mean, median, and mode would be 5'8". And the reason why mean, median, and mode are all the same is because this is considered a normal distribution. This is what normal distribution looks like. Okay, and under normal distribution, your mean, median, and mode should be the same number, or very, very close to being the same number. So when can we have mean, median, mode not being the same number? So let's take a look at something that is, well, when you don't have normal distribution, that's when mean, median, mode are not the same. So let's take a look at something that is not normal distribution. Okay, so here is something not normal distribution. We can tell it's not normal distribution because it's definitely not symmetrical. So now we have to figure out the mean of this thing right here. Now it's a little bit hard, and I will never ask you to calculate where the mean is, but I want you to have kind of a rough idea of where it would be. So the idea is that imagine you had a teeter-totter. Okay, so here's your teeter-totter. And you had an object like, well, here's your teeter-totter, right, like that. Okay, now imagine you had lots and lots of objects right here. So you had lots and lots of stuff right here. So okay, and then on this side right here, you'd only have one. Okay, now this would obviously fall down this way unless we moved where the fulcrum was. Okay, so what we're going to do is we can move this fulcrum way over here like this, and then this would be kind of balanced. It might balance at that kind of spot right there. Okay, and that's kind of what it means to find out where the mean is. So if we kind of go back to this graph right here, is that, yeah, we have a lot of people or a lot of whatever this was sampling at this location right here. We have very few things that are sampling right here. But this is pushed out so far. So even though there's so few way over here, it's going to be kind of dragging the average in this direction, if that makes sense. So since it drags that average in this direction, because it's such a one person with such a high value, it's going to be dragging that average, or in other words, instead of average, it drags that mean way over in this direction as well. So our mean would probably be something right around, if I'm guessing, maybe somewhere around here. And this would be considered our mean. And I'm just kind of eyeballing it up. That's what I would guess. But let me give you an example rather than using weights and all that kind of stuff. And I gave an example in one of my previous videos. Like imagine if we had wages and we had a whole bunch of people making $10,000. That's how much they make at this company: $10,000, $10,000, $10,000. Okay, so we had a bunch of people making $10,000. Now we have the owner of this company, or imagine these are like Amazon workers or something like that. Okay, they all make $10,000 at this company, and then we have Jeff Bezos himself, and I have no idea how much he makes in a given year, but he makes a lot of money. Okay. Um, so this is how much money he makes. Well, if you took the average of this, the mean of this, it's going to make it look like that people are making in the millions and millions of dollars, right? In other words, it's going to be pulling that to a very, very high number if you took the average of it. So same thing right here, even though it looks that it's way up here is where the mode is, it's going to be pulling this number way further down. So that's why the mean gets pulled way further down right here. Okay, so that's the balance point on our graph. However, now the next one is the median. So the area is equal on both sides of the graph. Now, if again, I would never ask you to calculate this from the graph, but we're going to take a look. And I would say, if I was to look at this, I would say somewhere in this neighborhood right here is where the median is. And that's just like completely just eyeballing it up. So if I was to say this area of green, provided that I can stay within these lines right here, that area of green should roughly be equal to, let's do pink, should be roughly equal to this area of pink. Okay, and I'd say that's pretty close. So these two areas are roughly the same. So I would say, yeah, this is a good location for our median. The mode is something that we should get every single time. The mode is the highest part right here. So here is the mode. So I'm just going to erase this little arrow. So right at this point right here, this is the mode. So before we said that, yeah, in normal distribution, mean, median, and mode line up perfectly. In not so normal distribution, or what we say skewed distribution, mean, median, and mode do not line up. So here's another example of some more mean, medians, and modes that don't quite line up because we have skewed distributions. Now, I'm going to take another look at one that I don't have a graph of, but we're going to make a graph of this. And that is something that is bimodal distribution. So bimodal distribution means we have two peaks like that. Okay, oops. And so let's do the easy part first is what are the modes? So right here, this is a mode. And since it's bimodal, we have two modes. Here's the other mode. Okay. Now, again, if this was a an object, where would we place our fulcrum, or in other words, our mean? And that would be right here. This would be our mean. Right in the middle. And the next thing is, what about our area? Area underneath the curve. Well, this would be our area under the curve. That's one side right there. And our other side would be this one right here. And I would say those look pretty darn close to being the same to me. So, in other words, this would also be our median. Okay. So here we have the modes are different, but the mean and the median are the same. So you can have that as well. So there's a lot of different ways, but this would not be considered normal distribution. This would be bimodal distribution. Here's our skewed distribution. If you have all three line up, then it's going to be normal distribution. Okay. Once you feel comfortable with this, try writing the quiz. If you still don't fully understand it, you can message me on Microsoft Teams, and I'm always available for tutoring. So you can message me and schedule that through Microsoft Teams as well. Okay, good luck.